Hey there everyone, today we'll be going through this histogram question, so let's start off by just reading it. So below is a histogram showing the scores for a class test that was worth 100 marks in total. Great. Now we are told that 40% of the students scored higher than an S number of marks. Okay, we don't know how many marks that is, but we know that 40% of students scored that. Now the key to this question is we don't have frequency density, right? Frequency density is usually on our y-axis. We're not given it. So we are not sure what the frequency of each bar is, right? The frequency is represented by the area. According to the formula, frequency equals to frequency density times class width, right? The formula states that, therefore, each bar and the area of each bar represents the frequency. Each area represents, therefore, the number of students who scored a certain number of marks. So, for example, in here, that would be some number of students that scored between 30 and 40 marks on that class test. All right, so we're not given the frequency density, so we're not sure what the frequencies of each bar is. However, we can randomly assign any frequency density in this case because it will be more apparent later on, but essentially in proportion, whatever we assign here, and we use those numbers to find out the frequency, in proportion, it will be the same to the real frequencies. In proportion, right? It won't be the exact same frequencies. It'll be randomly assigned frequencies, essentially. However, when we find the proportion of those bars, right, the area of each bar, proportionately, they'll be the same to the real frequencies. Therefore, we'll be able to find this S number of marks, which is somewhere around here probably. So let's go ahead and assign random frequency densities. So I'll go with just 1, 2, 3, 4, and 5 at the top. Okay, now let's just find frequency of each bar. With randomly assigned, again, I repeat, randomly assigned. So those aren't real frequency densities. I just randomly came up with them. Couldn't be any number. So let's find the frequencies, therefore. So we do 3 times, right? So frequency density times the class width. Class width is 10, 40 minus 30. So 3 times 10, that's just 30. So this bar area is 30. According to our randomly assigned frequency density, there are 30 students in this bar. So 30 students who scored between 30 and 40 marks. This isn't real, okay? I repeat, this 30 isn't the actual frequency, isn't the actual number of students who scored that many marks. Okay, because we, again, I repeat, we assign random frequency densities. And it will be apparent why it is important to do so and why we are able to do so later on in the question. So for the second bar, it's just 60 minus 40, which is 20 class width. 20 times 4, that's just 80. So this bar has 80 students. Third bar has 74 in here, right? 74 minus 60, which is obviously 14, times, so 3 minus 0.2, that's 2.8. So 2.8 times 14 is 39.2 students in that bar, which is obviously unreal because you can't have 0.2 number of students. Anyway, going next, in here we have a class width of 82, right? 82. So all we have to do is 82 minus 74, which is 8 times 2 minus 0.4, that's 1.6, times 1.6, that is 12.8 students in this bar. Okay, great. So in total, according to our randomly assigned frequency densities, in total we have 162 students, right? So total students, so let me write it as a subscript, so total S, that means total students, is 162. Now we can find 40% of them by just doing 0.4 times 162. That is equals to 64.8 students who scored higher than the S mark. Now, important point to note, higher, okay? That means we're concentrating on the right side of the S. So S, if we say it's somewhere around here, we don't know exactly where the position, but hypothetically speaking for now, let's say it's somewhere around there. That means if it's higher than S, that number of students is the area to the right of the S. So the area of the bars to the right of the S. So this whole area will represent 64.8. The way we find where exactly this S lies Well, all we have to do is 64.8 minus 12.8, and I'll explain why we do that in a moment. That gives us 52. So again, I'll repeat, S is somewhere around here. We are trying to find, so this area of this whole thing, right, of those bars, will be 64.8 students, right? All we did now is we subtracted this bar from it, and we are left over with this area here, which would be 52 number of students. So that would be in here, this area would be 52, therefore there would be 52 students in here. Then we do the same for 39.2, so 52 minus 39, 12.8. 12.8 students is the area somewhere around here. Now we don't know exactly where S lies, so if I were to draw this rectangle, right, this rectangle here, this one, I don't know where S lies, so I would represent S in here, but I know that this would be 60. So the class width of this bar would be 60 minus S, right? 60 minus S. Now the height, we know for sure, is 4, right? Right here, it's 4. So we know the height is 4. So area of this bar is 12.8. This area of this bar in here is 12.8, right? Because all we did is 64.8 minus all of these bars, right? We subtracted those bars, and we were left over with this bar only, which is 12.8 in the area. So that means 12.8 is equals to, right? Area is equals to 60 minus S times the height, which is 4. Then doing some manipulation, so we do 12.8 divided by 4, that gives us 3.2 is equals to 60 minus S. Moving S to the other side and 3.2 to the other side, we get 60 minus 3.2, right, equals to S. So final answer should be 56.8. And that's it. That's how we find it. So 56.8, somewhere around here. That's our S, which is 56.8. And that's it. That means if we were to draw around all of these bars, this would be the 40% of students who scored higher than S. Again, these we used randomly assigned frequency densities. So all of these frequencies aren't real. These frequency densities could be 0.1 or 0.2, or they could be like 10 or 20, whatever it can be. We allocated those numbers randomly. But the reason why we were able to do it is because if the total was 300 students, it would still be represented on the same kind of scale of the bars, right? It would still be in here. This whole shape would be 300. However, we used those frequency densities, so therefore our shape here, the area of this shape, is only 162. But proportionally, it would be still the same. The 40% of students will still be the area in here. It would still be the area in here. So the area here would be 40%, regardless of if we had 162 students in total or 300. So proportionally, it's still the same thing. So even if we had 300 students in reality and we used 162 students to find our answer, the S would still be 56.8, even if we used 300 students, 400 students, 600 students, whatever number we used in proportion, we would still get the final answer as 56.8 for our S number of marks. I hope this was helpful. If it was, please consider subscribing, leave a comment down below and like the video. And I'll see you soon. Bye bye for now.